Okay, so here we go. We're going to start trying to verify trig identities. Now, just as a reminder, we're going to kind of use these helpful hints to guide what we're doing, okay? All right, so the first example we're going to work is we're going to try and verify tangent of x sine of x equals secant of x minus cosine of x, okay? All right, okay, so sine of x, tangent of x sine of x equals secant of x minus cosine of x. First thing we're going to want to do is pick one side to work with, and in general, we want to pick the side that's more complicated, okay? Well, neither of these look particularly simple, but in general, when we've got addition or subtraction, that's actually more complicated than multiplication and division. Because multiplication and division, it's easier to do some canceling. So this side, I would say, is the more complicated side. So that's the side we're going to start on. All right, so we've narrowed it down to this side. So now, what we probably want to do is rewrite everything in terms of sines and cosines. And I'm going there because I don't recognize this as any of our, like a Pythagorean identity or anything like that. So let's start by rewriting this right-hand side in terms of sines and cosines. Cosine's already in terms of cosine. But secant we can rewrite as 1 over cosine. Okay, so now we've got this just in terms of cosines. Now, when we have addition and subtraction, we're usually going to want to do something like get a common denominator and combine terms together. So let's go ahead and get a common denominator here. Well, my common denominator is going to be cosine. This guy has a cosine in the denominator, so I'm going to need to get this in terms of cosine. I can do that by multiplying top and bottom by cosine. Okay, so where are we at now? So now I have 1 minus cosine times cosine is cosine squared over cosine. Okay, so now I have my common denominator, so I can say this is 1 minus cosine squared over cosine. Okay, all right, so now what? Well, now I'm thinking maybe I can use a Pythagorean identity here, because this involves a cosine squared. Okay. So remember, the Pythagorean identity we have that involves cosine squared says sine squared plus cosine squared equals 1. Okay. What I have is 1 minus cosine squared. But if I subtract cosine squared from both sides, I get sine squared equals 1 minus cosine squared, which means I can use this version of that Pythagorean identity to substitute 1 minus cosine squared becomes sine squared. Okay, so now I'm at sine squared equals cosine, it's just cosine of x. Okay, I'm going to move this guy up here so that we can see it easier. So again, we're at sine squared over cosine. Okay, all right, so now we're getting closer. Remember that since we chose to start from this side, right, our goal is to make this look like tangent times sine. Well, I've got sine floating around in there. What if I split this up? Sine squared I could think of as sine of x times sine of x over cosine of x. Okay. And then if I wanted to, I could think of this as sine of x, the sine of x, times sine of x over cosine of x, right? If I multiply these back together, I'd get sine times sine, or sine squared over cosine. Well, that's looking good, because now I've got that sine that I needed here. And then I just have to think, what is sine over cosine? Sine over cosine, that's one of our quotient identities. Sine over cosine is tangent. So look, I've rewritten this as sine of x times tangent of x, which is the same thing as tangent of x times sine of x. Okay. All right, there we go. We did it. We verified our first identity. Hooray! Let's do another one. Okay, so here's the next one that we're going to do. So cotangent of x over cosecant of x equals cosine of x. All right, so the first thing we're probably going to want to do is pick a side. Remember, we want to pick the more complicated side. Well, that's just cosine. So we probably want to start with this side and make it look like cosine. Okay. All right, so now we have cotangent over cosecant. Probably the next thing to do is to rewrite this in terms of sines and cosines. Well, cotangent is cosine of x over sine of x. And cosecant is 1 over sine of x. Okay. So now we're going to simplify this by remembering that remembering how we divide fractions. Cosine divided by sine divided by 1 over sine is the same thing as cosine over sine divided by 1 over sine, which is the same thing as cosine over sine times sine over 1, multiplying by the reciprocal. The signs cancel, and we're just left with cosine of x. There we go. All right, so next, we're going to try and verify that 1 over the sine of x plus 1 minus 1 over the sine of x minus 1 is equal to 2 secant squared of x. All right, first thing we need to do is pick a side to tackle. Well, I would definitely say that this side, the left side, is much more complicated than the right side. So we're going to start here and try and make this look like 2 secant squared of x. All right. Well, on our left-hand side, we've already got things in terms of sine, so it doesn't really make sense to try and rewrite everything in terms of sines and cosines. Instead, we're going to have to try that algebraic hint, which says things like, combine terms where you can. In other words, we're going to get a common denominator and perform this subtraction. All right, so I have denominators of sine of x plus 1 and sine of x minus 1. So my common denominator is going to be sine of x plus 1 times sine of x minus 1, which means to get my common denominator here, I'm going to multiply top and bottom by sine of x minus 1. And to get my common denominator here, I'm going to need to multiply by sine of x plus 1. Okay, so then when I perform the subtraction, I'll have sine of x minus 1 times 1. So sine of x minus 1 minus 1 times sine of x plus 1, or sine of x plus 1. Okay, all right, so now let's do some simplifying. So I'm going to go ahead and distribute my negative here. So I'll have sine of x minus 1 minus sine of x minus 1. Sine of x minus sine of x, that's going to cancel, leaving me with -1 and -1, or -2 on top. On the bottom, we have sine of x plus 1 times sine of x minus 1. All right, we're going to want to expand that using FOIL, right? This is a 2-term polynomial times a 2-term polynomial. When we multiply those together, FOIL is a handy way to do that, okay? So, FOIL says first, sine of x times sine of x is sine squared of x. Outside, sine of x times -1, negative sine of x. Inside's 1 times sine of x plus sine of x. And last, 1 times -1, which is -1. I've got a negative sine of x and a positive sine of x. Those cancel, which leaves me with sine squared of x minus 1. Okay, all right. Well, let's look at this guy. Sine squared of x minus 1. This looks like something we might want to try a Pythagorean identity with. All right, so what's the Pythagorean identity that involves sine? It's sine squared plus cosine squared equals 1. I have sine squared minus 1, so I'm going to rewrite this. So I have sine squared minus 1. So I'm going to move my 1 over by subtracting 1 from both sides. I'm going to move my cosine squared over by subtracting cosine squared from both sides. That'll give me sine squared minus 1 equals negative cosine squared. So sine squared minus 1 I can rewrite as negative cosine squared. Oh, and then I think we're almost there. We've got negative, negative, that cancels. And then let's use a reciprocal identity. 1 over cosine is the same thing as secant, which means 1 over cosine squared would be secant squared. So with that 2 on top, we have 2 secant squared. Verified. All right. So there's 3 examples of how we can do verify problems.